I like the addition of that music there. Welcome everybody. I'm Kyle Curtis. We are live this time, unlike earlier today and yesterday. We missed you guys. Steve doesn't exist outside of a live stream, so I missed seeing you yesterday, Steve. It's good to see that you're back with us.
I only exist when we're live. Just like if you're not looking at me, I just vanish.
Right. So it's good to see you back. And that noise is back a little bit. Yeah. Dave, mute Walter just a second until we get through the thing, and maybe that'll fix that. We're having a little sound thing. Walter, again, it's coming back through. So I'm not sure how we're gonna fix that. Just give us just a second, guys. Yeah. Maybe.
It's gonna be one of those days. You guys don't even know what's happened already before we went on air. It's gonna be one of those days.
Yeah, I had a car issue that left me 10 miles from my house without my phone because it died. So that's why we're late. It's my fault today. This time I had an issue come up, but we'll get through it. We have gotten through these before, and we'll get through it this time. But yeah, we missed you guys last night. Good to be back. We are 28 away from 10,000. So thank you guys so much for that. As I said earlier today, we couldn't do this without you guys. We appreciate all the support, and we're excited to be hitting that big number. Maybe by the end of this show, share this stream. It's going to be a great discussion between these two very intelligent men. I'm going to try my best to keep up. I doubt that I will, but it's going to be interesting nonetheless. So who do we have today? We have Dr. Garte, as obviously, this is going to be a lot different from him than Sunday. This past Sunday, he was with us with Furious George. And by the way, has anybody sent you a link to George's response video?
I did.
Yes. I had the pleasure of watching it, yes.
Okay,
Wasn't it magnificent?
Don't get angry, Grandpa. Don't get angry.
Grandpa.
Yeah,
that's right. That's right, Grandpa. Yeah, Grandpa.
And I'm a failed professor that's teaching everybody how to just not believe in God. Whatever the hell that.
And I'm the guy that disclosed to him before we went on air that I'm gay, like it was a secret. But I will say
God.
Yeah.
What? Wait!
I will say,
this, Dave.
the best part of that entire response video was that he gave everybody an arrow when he was talking about them. Like he went down the line, gave everybody an arrow. I like that I got the pink arrow. I thought that was very, very fitting. Because
real clever.
When he said, he goes, yeah. So thanks, George, if you're watching.
It should have been a rainbow arrow. That would have been better, actually.
And all the way from Germany, we appreciate him joining us from across the globe. We have Walter Veit. Welcome, Walter Veit.
Hi, it's a pleasure to be here.
I follow him on Twitter and see a lot of his posts. And when Dr. Garte sent me a message asking if there was a possibility we could do a discussion with somebody who talks about genetic engineering, it was kind of fate, I guess, because I was just looking at Walter's Twitter profile. So it was like, okay, cool. We've got this. So we're not going to run through what we've got coming up in the week. If you saw our stream from earlier, you'll be able to see what we've got there. We're going to go straight into it, and I'm going to let Dr. Garte go ahead and introduce yourself, and then we'll go over to Mr. Veit, and he can do the same, and then we will hear about Mr. Veit's paper that he recently or that he's working on. I'm a little tongue-tied because I'm still got that adrenaline from rushing back. So, Dr. Garte.
Okay, thanks. My name is Cy. I can't get Kyle to call me Cy, but everyone else tries to. And I am a biochemist. I'm a retired scientist. I worked in academia for about 35 years. Then I went to the NIH for about 6 years as more of an administrative position. But I still keep tabs with science. I'm actually doing some theoretical biological work on gene regulatory networks at the moment, but I don't have a lab. And so I missed out on CRISPR-Cas9 because I don't have a lab to try it out in, which is a shame. But But anyway, it's a fascinating technique, which we'll probably get into a little bit. And I also happen to be a Christian, but I'm not sure that will really come up in this discussion. I don't think there's much relevance for that, but we'll see. You never know. And that's about it. I've been on the show a few times, so some of you probably already have heard me.
Yeah, quite a few. You're number 3 with the most appearances. I think you're at 5 today. Yeah, 5 appearances.
Yeah. All right.
Okay, Mr. White, tell us a little bit about yourself, what you do, and where you stand on genetic engineering.
All right. My name is Walter White. I'm currently studying Bayreuth, philosophy and economics. And, well, I'm a philosopher of biology. So I work on issues regarding the nature of what humans are, human nature, what we can learn from biology, if it tells us anything about ethics, and, of course, what new technologies in biology change on our ethical perspective. And, well, I'm a huge proponent of genetic engineering on humans, which will be the focus on this debate. Right.
Mm-hmm. Excellent. Okay, Doctor, I tell you what, let's, Walter, tell us about your paper, because you were speaking earlier today, I believe, somewhere in Germany. So like I said earlier before we started, this is way over my head. I'm not even going to try to pretend like I know anything about this. So we kind of want to get your feel, and then Dr. Garte will ask you some questions based on, where your stance is on that, because I can't offer anything in terms of quality here. Maybe Steve can jump in a little bit, but it'll kind of be a discussion between the two of you. So what's your paper about?
All right. So in January this year, I published a paper in a philosophy journal called Procreative Beneficence and Genetic Enhancement. And, well, imagine a world where everyone is healthy, intelligent, long-living, and happy. Well, intuitively, this seems to be a wonderful world, right? But unrealistic. However, this recent technology, CRISPR-Cas, makes this dream perhaps a reality. And even if the technology is not that far advanced to create this sort of superhumans which are healthy, happy, highly intelligent, we still need to ask the question whether it is the moral thing to do to use this technology. And I'm arguing, well, considering parents are kind of obligated to make the life of their children go as best as possible to the same extent, if they're able to choose between particular genes to make the life of their child go better, then they would have the obligation to change the genome of their children. Right.
Okay. Dr. Garte?
Okay. So we should define a few things maybe at the beginning, although I think your statement's pretty clear. When we talk about genetic engineering and changing the genome, at the moment, using CRISPR and Cas, which is a very good technique, very simple, a lot of labs can do it, we're really, so far, mostly talking about health. We're looking at somatic cells, which means they're not the germline cells. They're not the cells that get transmitted. But we're looking at modifying genomes in somebody's cells that don't get passed, the changes don't get passed on to the next generation, but they can cure people of terrible diseases. And I don't think there's any question about that. I mean, that's not what we're talking about at this point. Clearly, that's a technique that it's not quite ready, but it's getting pretty close. And it will probably be within the next year that we will see people cured of some really bad genetic diseases and possibly even broader diseases. So that's one issue which we can probably put aside. I'm just mentioning that to make just so we get that out of the way. But it sounds like what you're talking about is actually the step further, which we're not quite there yet, obviously, and that is the idea of truly genetically enhancing the human race. Is that fair? What I just said?
Correct.
Is that a
We want to
fair
create
summary?
Yes, we want to make humans that are expected to lead better lives.
Okay. So I guess my first question is, who defines better?
And that's a very good question, and that's basically the question most people ask first. And
Right.
I don't commit myself to any particular view of what a better or best life would be. In fact, I just say, well, take all the major accounts of what a good life is and just say, well, if a particular enhancement would satisfy all of these three accounts, which are, well, preference satisfaction, which is a kind of desire account, we're satisfying the desires of particular humans, then we have this kind of happiness notion. So it's a brain state. And the last very popular view in philosophy is objective list theories. And then we have things there like education, which makes your life go better, even if you really hate going to school and if you never intend on having high education jobs, or you want to work in a low qualified job, whatever, it doesn't matter. Education makes your life go better, whatever the case is. So what we get here are some kind of all-purpose goods, which would qualify under all of these accounts. I argue there's quite the number of things which would qualify, perhaps intelligence. Of course, we want to get rid of diseases. We want to make people happier and perhaps more empathetic. And all of these things, I think, are expected to make your life go better.
Okay, but you would leave the decisions of, let's not talk about the genes yet. We can get to that later. But you in terms of phenotype, you're like more intelligence, maybe taller, maybe stronger, maybe things that make people happy, whatever that might be. The decisions of what phenotypes to improve would be up to parents. They could choose any phenotype they're interested in, or who would do that choosing? Would everything be allowed in this view, or would there be some things that would not be allowed? So right. How would that process work?
So the obligation is obviously an obligation for parents. That is, if wannabe parents choose to have children, then they are obligated to create the life that is expected to be best as possible. What does that mean? Well, depending on what your information is, you may have very different views on what particular genes might help you with, right? The obvious response to that is you should gain as much information as possible, gather data that makes it likely that your decision is well informed. And furthermore, you're not going to be the person working on the genome of a particular embryo. You're going to ask a doctor who does this procedure all the time, basically. We're talking, of course, here about a future state, perhaps a kind of utopia. But yeah, this is going to be left to research. And we will have to do a lot of research into that, because otherwise it would just be a genetic alteration. And we can't say that it's actually a genetic enhancement, which is expected to make the life of someone go better.
Okay, well, I understand that, but I'm still getting back to this idea of, there could be a family who decides that they want all their children to be tall. They just don't want any people short in their family. Maybe they themselves are short and they suffered for it. So they would love to have everybody be 6 foot, all their kids be 6'2". There may be another family that really doesn't want any girls because they really like the idea of having boys. And so that's fairly simple to do. Actually, some people do that even now. There could be another family that decides that they want their kids to be brilliant in math, or to be great artists, or something else. And what you're suggesting is that the choice of the phenotype, I understand that the actual genetic work would have to be done by researchers, and some of these phenotypes obviously are very hard to adjust genetically, as you well know. But let's leave that for the moment and just say that what you're suggesting is that parents would be educated enough to decide what phenotypic characteristics their children would have that would make them happier. And that would have, I mean, I can think of a maybe, you know, there would be maybe a parent, a couple of bank robbers who were married and had a kid, and they might look for phenotypes that would be useful in the profession of bank robbery. You know, I mean, I'm being silly, but you know, that the point is that what I hear you saying is that you're thinking that people will somehow, with education, make the best choices for their kids. And I find that if we look around the world today, kind of hard to, you know, believe that that would actually always happen. So I guess what I'm asking is, and I know you've thought about this, what philosophical basis do you have for saying that whatever parents decide for whatever reason would be good for their kids, that would actually work out well for society as a whole? Do you see anything going wrong with that idea?
Right. So it seems intuitive that parents should do what makes the life of their children go better, right? But in many cases, right. But in many cases, this can go against the interest of the society, right? Perhaps you help your children cheat in a test. Well, this could make their life go better, depending whether they still are responsible in their lives. But in many cases, this could make the lives of other people go worse. Think of an enhancement like making people less empathetic. So perhaps people become more ruthless. They go to the market and they just try to abuse every loophole that makes their life go better, irrespective of how it affects other people. Well, and here I say parents would still have the obligation to do it. So there's another consideration, and that's basically politics. And here politics can just put limits on what kinds of genetic alterations are legal to do. Because there's always the option, what are we allowed to do and what should we do, right?
Right.
So there is a conflict, I grant that, but I think it can be resolved by putting limits on what kinds of genetic alterations are allowed. And I think in many cases, even if it seems intuitively a really bad idea, there's plenty of dystopian novels that if we introduce these technologies, you think of 1984, Brave New World. That seems to be, oh no, we get this really unequal society. The people who are on top, they get enhanced even more. Well, we don't want it, right? We want a society that's more equal, not less equal. So we don't, because of that, we don't even consider the advantages of genetic engineering. But what I'm saying is that it can actually solve both issues at the same time. We can get a more equal society by making this technology freely available, or at least supporting families who can support it. And
okay,
if you
that's
all
a very.
get,
I'm sorry. Go ahead.
Yeah.
No, finish.
So it makes. Right. So take, for example, a runner. He trains a lot. And if you are at this Olympic level, then you have trained hours and hours just to get just a few meters more in a particular amount of seconds, right? There's a huge amount of work that has to go into that. And it's the same with genes. To make someone more intelligent is much more easy if the person is less intelligent to begin with. And I think the same would apply to all kinds of enhancements. So it is easier to get people to a particular level, but not far beyond it. There are natural limits there. So even if they are possible, they might be so prohibitively expensive that it's not even useful to use that technology. And people would get more equal rather than less.
Okay, I have a question. I know you're an expert in evolution. I've seen some of your work. So I have an evolutionary problem with this, which has to do with what you just said about making people more equal, because one of the byproducts of that idea, very few parents are going to decide to make their children fatter, weaker, shorter, worse looking. Okay. Most parents are going to want to improve their kids. And so what we're going to end up with, if we do this, is a human race that is much more homogeneous with much less variation, genetic variation, than we have now. And don't you see a danger in that for the long-term survival of the race? I mean, we know that humans are already genetically not diverse at all compared to other animals. And if we went this route, what do you think about the possibility that we would end up going extinct because the climate changes and all of a sudden everybody's very tall and they can't survive? I mean, just as an example. So what I'm saying is, there's an evolutionary argument against the idea of making everyone equal.
Right. So first of all, once we get technological progress in this technology, the only genetic enhancements we will actually be able to do at first are eliminating certain diseases. So we're not creating these kind of clones just because we know, oh, this particular person has just a perfect set of genes, and everyone who wants to have children should just clone this particular being, right? We're not that far. And we don't have that much knowledge of the genome. Of course, perhaps far into the future, this may become a problem. But should we let people be born with diseases just because we are afraid that, oh no, this eliminates some pluralism of genes in a society? This seems to be a pretty drastic idea. Just telling people with some diseases, well, we could have cured you, but we didn't because we wanted to sustain some level of variation in the population. That seems.
No, but I agree with that. But I agree with that. I mean, that's why at the very beginning, I said we have no dispute about curing diseases, even in the germline. I mean, I don't have any problem with that. It does reduce variation, but to a very small extent, because, as you know, these genetic diseases are very rare. And even to the point of changing the genome in future generations to prevent cancer, to prevent various forms of heart disease. And we know that some of those genes, so that's not even that hard to do. So I'm not asking you about that. That I think we agree completely. And I don't really know anyone who doesn't. Well, there are a few people who don't agree with that, but we'll leave that. No, I'm talking about, phenotypic enhancements that are not disease related, that are just, as you said, making people better, improving. And that's where I'm worried about this evolutionary danger that could occur, far in the future, but not that far.
Can we kind of clarify for the audience, because I don't want to get too confused with the nomenclature, because they might be able to kind of parse this out a little bit. But can you kind of explain to them the difference between gene editing as far as the somatic line and the changing of the phenotypes, rather than what he's suggesting? Because obviously, like you said, Cy, I don't think there's any argument. People can say if there's a disease, we should try to fix that before a baby is born, especially if it's a debilitating or deadly disease. But I think he's advocating the position to change not only those things, but obviously just general phenotypical traits. So can you kind of explain to the audience for that, the difference in the argument there? Because I think it's a critical point.
Gene editing and any kind of genetic modification can occur in two very different ways. One way is that you change the genome of individual cells in the body, which is all the cells in the body except the germ cells, sperm and eggs. Okay. All of those, making any change in any of those cells can cure most diseases that we know of, most genetic diseases. but they will not be, those changes will not be passed on to the next generation, because what you do to the somatic cells, your liver, your skin, your lungs, whatever, doesn't get transmitted to the next generation. The only way to make a permanent change in the germline is to, change the genome of germ cells, or, for example, in embryos. And at that point, you've actually modified the human race to some extent, because that's not reversible. So there's two ways to go about changing the lives of children. I mean, one way, which I think Walter might be talking about, but I didn't believe that. I didn't think that, is that, you would do somatic cell gene engineering with every child once they're born. Is that what you meant? My impression was that you were talking about permanent long-term germline modifications. So I guess we should clarify that first. Yeah, right. There's a big distinction.
I'm talking about embryo editing.
Okay, so that's germline. So in other words, yeah.
We use in vitro fertilization. We edit the embryo. We want to create an embryo which is expected to have the best possible life. And well, you mentioned health, and you granted that we should use this technology to cure all kinds of diseases. But what is the definition of disease you use? What is health according to you?
Well, that is a very good question. I don't have a great answer. I know that's a philosophical issue. And I think that's where a lot of guidance is needed from the public, from philosophers, from ethicists, from people who are thinking, from people with expertise in morality and ethics and long-term vision. And I've heard some of these people speak. But that's a hard question, because one response I once had was, well, you say you shouldn't make people shorter, but what about, you shouldn't try to cure people who are very short. But then what about dwarfism? Is that a disease or what? And it is a disease. So, it's not an easy distinction to make. So you raise a good point. And I don't think I can make that distinction very easily. But I think what it is that there's a continuum. So there are some things, I think, in my own view, is that there's no question we should go ahead and do it. If we're curing sickle cell anemia, yes. And we know the gene, we know the mutation, that's probably going to be one of the first things to happen. If we're talking about cancer, it gets a little more complicated because there are many different genes. It's a very complex disease, but it's not out of the question. If we're talking about anything else that we now define as a disease, I think, that continuum begins to say, well, maybe we should be careful about certain things, because there are populations, for example, who we consider disabled, who don't consider themselves disabled, and they don't want to be, quote, cured. So now we start entering a very shady, shadowy realm of ethics and personal preference that, it's not objective, it's very subjective. There's a group of deaf people who are opposed to the idea of curing deafness, because they feel that their disability is somehow part of them and they don't want to be, quote, cured. That from there, we go into things that, are on that borderline between disease and just unusual phenotype. And it just gets harder and harder. And when we get to other things, like being smarter, being more intelligent, frankly, I don't know what intelligence even is. I don't think we have a good measure for intelligence. I know people who sometimes somebody would say they're dumb because they don't do well in math, but they paint beautiful pictures. So what is intelligence? And how do we know so little about the genetics of intelligence? As you said, we're very, very far from that. But if we get closer, do we really know what we're doing? Will we ever know what we're doing? And I'm not sure. That's really my question. I don't have a very firm position, by the way, on any of this. It's just, I have a lot of questions and doubts is really what I'm raising.
Maybe Walter, can you tell us what CRISPR-Cas9 is used for now? What the what we have used it for, what the limitations are, what we expect it to be able to cure, such as like sickle cell anemia or maybe one day diabetes. Can you kind of give the audience maybe an idea what CRISPR-Cas9 gene editing actually entails?
So you've raised a few points. CRISPR-Cas9 is mostly used at the moment on plants, animals, insects, just trying to figure out what we can change. We try to test theories about evolution, and there's a lot of startups actually researching how we can apply this technology to humans, change soma cells. I'm more concerned with changing the germline, because this is really where the future lies. The research there is advancing really fast. There's millions of dollars pouring into these projects, and there's new discoveries almost every week. So I'm not up to date actually what the current state is there. In regards to health, I wanted to add this point that in my paper I go to some extent to the point of view of Julian Savulescu, Guy Kahane. They are professors at Oxford at the Center for the Future of Humanity, and they argue against this common sense notion that we use in daily discourse when we talk about health, that health is some kind of statistical norm or average, what we have in a population. But a statistical norm doesn't necessarily have any normative bearing. What we should really be concerned about is whether something makes life go better. And if you have a definition of health that is related to, I don't know, a statistical average, then this is entirely arbitrary. So I grant it. There are some communities which are disabled, but they don't want to be considered that. Why? Well, it tells them their life is necessarily worse, right? And that is a separate question of what we consider disease nowadays. And the World Health Organization has a very particular definition of what health is. It's a general state of well-being. And this is what I'm arguing for. We should have a normative definition of health. And then the distinction between health and well-being basically gets eliminated. So we agree we should get rid of diseases. But what I'm saying is there's no distinction between a disease and an enhancement like better eyesight that goes beyond what is normal. Perhaps a better immune system, which goes beyond this average in a society. That doesn't count as curing a disease, according to you. I say there's actually no normative difference. What's your response?
Well, my response is if you can fix the problems with my teeth, which a lot of other people have, I'm entirely on your side, because, human teeth are a disaster, and I can testify to that. So I'd love to see that. No, I hear what you're saying, and I think it's very hard to raise an objection to that point of view, because why wouldn't it be better if all humans could see better, didn't have bad backs when they tried to pick something up? I'm speaking a lot from personal experience here. And, could not have their teeth go rotten on them all the time and eat whatever they want. Could change their metabolism so that, sugar is no longer a problem. Lots of good stuff.
Amen.
It sounds great. And how can you argue against that? But you haven't answered my question about variability. The problem is that all of those enhancements, assuming that they're done equally among the whole population, which you agree would be important, all of those enhancements will end up with a human population that's even more genetically homogeneous than it is now. I mean, do you agree with that or not?
Right. To some extent, that is obvious. I'm arguing equality would increase in virtue of eliminating the genetic lottery, which is responsible for a lot of difference in success.
Sure.
However, having these equal genes, having a society of people who are almost entirely equal in their genetic code, that's not necessarily the best way to lead a good life in a society, right? So suppose you live in a society where all males, at least, and all females, they are almost clones of each other. But we have a market and we fulfill specific roles. There's division of work. And depending on what is needed right now in a society, depending on the environment, different skills might make your life go much better. If everyone has the ability to become an athlete, there's really no point in boosting your fitness level to a point which would have trade-offs with other abilities, such as intelligence, perhaps, right? So I think a lot of this worry can be discerned by just pointing out that in virtue of having a market and different skills that are necessary for different jobs, well, we will have some variation. Is it enough for your worry? Maybe, maybe not. But that depends on how far the research goes. And I don't think we will ever reach the point where we create this, I don't know, Star Wars clone trooper army, where we have the perfect soldiers, right? I don't think that's very likely, but I think that's what comes to mind when people think of genetic engineering. We don't want to have a Star Wars clone trooper army. We don't want it. That seems to be maybe that's yeah.
Well, I agree with you that I don't want that either. I don't think anybody here does. But the question is, once this approach is starting to be used, it can be used by anybody, anywhere, for whatever purpose they want. And there are maybe people in this world who would love to have a clone army, who would love to have a population where, let's say, just to throw out an example, the men are all strong, brave, not too smart, great soldiers, and, you know, the women all love them, so that, you know, everybody's happy. But it's a warrior society, and I don't know how great that would be, frankly. So right. I guess what I'm worried about, I mean, what I'm coming across as, and deliberately, is somebody who's a little worried about this approach, more than a little worried, a lot worried, partially because of the evolutionary problem of having a more homogeneous population, but there are other reasons too. And one of them is the potential for misuse, which I've only touched on one of. I'm sure everybody can think of a few examples of where some society might decide to genetically engineer people to, quote, improve, where their definition of improvement is far from what any of us would agree is an improvement.
Right. So now, without mentioning the term, we've entered the area of eugenics, right? So exactly. The state decides, well, this particular set of genes is just better and other sets need to be eliminated. So the question is, what's the difference to what the Nazis have been doing, right? So some people in this debate don't even want to mention the term eugenics because it's very heavily loaded with this historical baggage. Right. Can you even make a distinction here? There's a paper called Liberal Eugenics, which seems to be almost, well, an oxymoron of terms. No, well, this is a decision for parents. This has nothing to do with the state. Perhaps in practice, this will to some extent influence each other. After all, if parents are obligated to use this technology, the state perhaps has some incentive to at least advertise the usage of this technology, just like what we do with vaccines, right? Parents seemingly are obligated to make their children undergo this procedure of vaccinating them against several diseases. Some parents don't. The state doesn't force them to do them. Perhaps he should do that. But the state at least advertises the usage of that. So,
well, that's a very interesting example, because what happened, at least in this country and also in Great Britain, as far as I know, was after the hysteria of anti-vaccination spread, thanks to some actresses and public figures who were believing a fraudulent scientist who actually has now been barred from practicing medicine and doing science, Andrew Wakefield, if I remember that's the name. By believing him, we had a big problem with people deciding not to vaccinate their children on their own. The state took a hand, because that is a public health danger. In other words, when you send kids to school unvaccinated, you are endangering all the children. And in fact, there were big measles outbreaks here and in Great Britain, and I believe in some other places in Europe, but I don't remember the details. And so the state, and in terms of local school boards, began saying, no, you can't bring your kid to school unless you show they're vaccinated. So when you get to the point where parents make decisions that are not only bad for their own kids, but bad for the public health, they don't get to do that. They're not allowed to do that. The state will come in and say, sorry, you're endangering the lives of everyone else's kids. You can't send your kid to school unless they're vaccinated. So at some point, the state very likely could come in. And now this is the example I gave is one where I'm in favor of the state coming in, obviously, because I'm a public health advocate. But you could also reverse it. You could have a state that is not so careful about the public health of people, but decide, yes, you will produce a soldier. That's the law of this land. And that soldier will, do what we tell him to do. So how do you now, let me just, before I say anything else, I actually would like to stop, because Steve and Kyle, this conversation is actually no longer very technical or scientific. We're really talking about ethical,
It's
philosophical, moral. Yeah. So you guys should jump in with comments and questions, because, this is we're not talking about the details of CRISPR anymore. We're talking about,
we do have a lot of questions. We do have a lot of questions coming from the live chat, and once you guys
that would be good.
wind down from your talk, we'll ask you guys the questions. But right now, you guys are doing. I'm fascinated. This is actually, I can keep up with it a lot better than I thought. So I like the direction that it's going in.
I like the idea. Go ahead.
Go ahead.
I like the idea of bringing other people in, because I'm not a philosopher. I know a little bit about this. I have some ideas, but I haven't studied it. And Walter, has some very strong and specific ideas. So I've asked him a few questions, but I think it would be good to hear from other people as well.
Well, the efficacy concerns that I have are pretty straightforward, and I'm sure that what you have as well, Si. When we start messing with artificial selection, even with like we try with dogs, and we have different breeds. Dogs have, because of lack of genetic diversity, they become more sick. They don't have long life expectancies.
Right.
When you're talking about editing the gamete line, do you not fear that we might lose the amount of genetic diversity we have in the populations now? Obviously with somatic engineering, I don't think anybody's going to have a problem with that. That's not passed on. And I agree. The conversation then goes to which diseases should be cured, which ones shouldn't we? And that's a great discussion to be had. But my big concern is when you start editing the germline, that's when I'm like thinking, okay, now you're really fundamentally changing the way natural selection works, because you're artificially selecting now for various phenotypes. Do you see a problem there?
So in obvious ways, natural selection is not really acting that much on humans in modern day societies anymore. So we're really not that well adapted to the society, the environment we live in now. We really crave for sugar. We become fat when we eat the food that's high processed. Maybe we could come up with some changes which doesn't make people really fat when they have this modern age diet. So the question really is, what to do about the lack of diversity. Will we just become like dogs? You can think of these really highly bred small puppies which really suffer. They can't really breathe, but they're really nice to look at. Well, that doesn't make the lives go better. They were bred for a specific purpose, to please us. The question that I raise is, what should we change to make the lives of humans go better? So in a sense, how should we breed dogs that they would have better lives, rather than asking, how should we breed dogs so they satisfy our desires? I'm asking, how can we satisfy the desires of humans? And there's a thought experiment, and I wanted to add this to Sai's point. Well, imagine the society which is of kind of this Nietzschean idea that was explored in Star Trek and other sci-fi series. Imagine the society where you really have a warrior society. It's really patriarchalistic, and males fight against each other in order to have access to females. And in such a society, what should count as a genetic enhancement would be very different from what would count as a genetic enhancement as in the environment we live in, right? So the point is that I'm trying to make here is, well, environment does matter. And we need to be concerned with the environment we live in. If the genetic enhancements that we should do, for example, well, if we have scientific data that people who are very tall, with blue eyes, blonde hair, they do better in a society, then perhaps we should change the environment that would make parents obligated to actually use such genetic engineering tools, right?
Steve, did you want to follow up on that before I ask mine?
Go ahead. Go ask your question.
Actually, Sai, let's get you. Do you have anything that you want to add onto that point before?
Well, I have another question, but why don't you go first? And
sure. Well, mine's going to go in a different direction. So you go ahead and ask.
Yeah, mine
yours,
would
and then
too.
when you get... Okay.
Well, mine's also a slightly different direction, but so you go first.
I just wanted to ask if there's a way. Could we get to the point where you can edit things like personality traits out? You know, whether it be a predisposition to hate, or you know how there are some people who just have bad personality traits. I'm going to sum it up that way. Can you get in there to that level and actually manipulate people's personalities? Would that ever be a possibility?
Right. So actually, the majority of the literature right now is on moral enhancement. How can we make people actually more moral? And in a lot of ways, this seems to be a bit counterintuitive, because if you act people more morally, then this might not be in their interest, right? It might make their lives go worse. But actual research shows that the opposite is the case. If you look at psychopaths, then this folk idea we have is that psychopaths are these really intelligent people who can fool others, and they get all the money. They get to the top of some company, to the very top, there's a manager, and they have millions. But the actual reality is that this is perhaps 1% of psychopaths. All the others have huge problems in dealing in our world with other people, in having any meaningful relationships, to have any trustworthy relationships, which is important. They're really depressed, they're sad, they are angry, and morality actually helps people to make their life go better. And if you really like to be moral, then it also makes your life go better when you act morally, right? So what I'm trying to say is, well, making people more moral will not only make their lives go better, but obviously the lives of other people. And perhaps we shouldn't enhance intelligence, because that makes people depressed, apparently. But making people more empathetic, that might make the lives of people go better, and also of the society.
And I know, Sai, you're going to want to, yeah.
I want to comment
with the moral thing, you're going to go, yeah.
Yeah, I want to comment on that because, the literature that I know is slightly different when it comes to genetics and morality. Let's go back to some very basic genetics. Genes code for proteins. Okay. So, and even in fairly simple things like skin color or certain diseases, it's not one gene, it's several genes that interact with each other, and there are different alleles, and there's huge amount of complexity. When we start talking about behavioral traits like being moral, there may be some genetics involved, but the studies that I know show that when they do identical twin studies and other studies looking for the genes that affect some fairly strong behavioral patterns, the average is something around 30%. It can go as high as 50% genetic, and the rest is environmental. And this is that whole nature-nurture divide. And as far as I know, the current consensus is that it's pretty evenly split, and depending on what the behavioral parameter you're looking at. But morality is so complicated, even as an issue, even to define what morality is. I mean, we've had Twitter debates on morality going back forever. And
Every
then
day.
to find genes that make you a better person, more moral. We're talking way in the future, if ever. I mean, I find that one a little bit hard to grasp, just scientifically.
So, I mean, often when you see some news article and it says, oh, we discovered the gene for X, we can cure this disease now. Well, what actually happens is that we didn't just discover one gene, but a whole bunch of genes which, in a complicated way, act together. But that's not what people want to read about. So when people hear genetic engineering, then they think, oh, we can alter this one gene and this causes this. But this whole nature versus nurture debate in philosophy really ceases to exist, right? Because there's not a single gene which causes anything without the environment. And the environment without genes doesn't have any effect either. A gene can have the opposite effect depending on environment, right?
That's right.
Really, we need to think of what environment current humans live in. So parents need to think about what is the environment their child will grow up in, because that's the most important thing in their gene environment interactions for their child. What is this environment? Well, that depends on the parents, that depends on the society we have. Perhaps we should change the environment. And that will then also change what we consider as genetic enhancements. So I agree. This is
I agree
a
with
complex
that.
issue.
Absolutely. Yeah.
I
agree with what you said. Yeah. And I think what it raises is the question of, is it really possible for anyone to predict what environment their kids will grow up in? That's kind of tough. I mean, my parents couldn't predict the environment I grew up in. Nobody was predicting cell phones and the technology we have. And I couldn't predict the environment my kids grew up in, and so on and so forth. So, it's only been, let's think about this. It's only been 80 years since the world recovered from the shocks of the 1930s and 1940s. And it's a pretty good environment these days, but hasn't been around that long. And, we have to be pretty optimistic to think that we're over the hump and we're never, ever going to go backwards in some way and have an environment that's going to be much more difficult for people to survive in. It's true that we in this chat, and most of the people probably watching, live in a pretty nice environment, historically speaking, but there's an awful lot of people in the world who do not today. And we hope that their environment will improve. And I think that's what we need to work on. I agree with you. We need to work on improving their environment, and the genes, maybe, but I don't think that's the first priority.
Right, I agree. So even if we grant that we should use genetic engineering, well, perhaps we should change the environment first, because that really hinges upon what we should use as genetic.
I agree with that. Yeah.
Right.
Sai, you went in a different direction than I thought you would with the morality thing. I thought you would jump on the who defines what morality is aspect.
Well, that's another question, but there are many questions. I did want to make one other point about the entire approach, if I may, which is an analogy to something that I've recently become interested in, which is the problem of invasive species. That it sounds like it has nothing to do with this conversation, but it actually, I think it does. You know, invasive species are a great problem, both in the US and in Europe, where species that were never supposed to live in a particular ecology, in a particular environment, are suddenly there, okay? And Asian carp, for example, certain flowers, certain plants are brought in, go into an environment where they have no enemies, where they have no predators, they live very well, they kill everybody else, they cause a huge amount of damage. And it's a major issue throughout the world, basically, is the presence of invasive species that really damage the ecosystem in some ways irreversibly. Now, in some cases, those invasive species were never predicted to be harmful. There's a particular flower, I don't remember the name of it. I think I have it here somewhere. Well, maybe not. Yeah, here it is. There's a flower that's it's called winter hyacinth, and it's an aquatic plant which was brought to the U.S. from South America. It's an ornamental. It's absolutely beautiful, but the problem is that it starts to form mats, very dense. It cuts out the sunlight for everything living under them, and it clogs waterways, and it is has become, you know, a major problem. So that was not predicted, and people brought Asian carp in because it was, you know, has a lot of valuable properties for clearing out waterways, and it's an incredible pest. There's so many examples. I mean, I don't want to go any further. But the reason this is analogous is when we make a change to the human genome for the purpose of improvement, the genome is just as complicated, and not just the genome, but the way the genome interacts with everything else, and you agree with that, it's just as complicated as an ecology where you put a new species into an environment where it never was before. If you now change the genome without being careful enough, without testing, without making sure it's really not harmful, we don't know what the results are going to be. And the problem is we can't go backwards. Just as it's almost impossible to eliminate some of these invasive species once they get a foothold, once we have changed the germline, it's permanent. And it's nothing we can do. And if it ends up having unforeseen negative consequences, which I don't even know what they could be, but whatever they are, we know that that very delicate balance is very delicate. It's the balance within the cell, within the person. And we already know that, you know, there are some genes that if they mutate, they cause all kinds of horrible phenotypes for diseases that we would never predict, knowing what the function of the gene product is. And I guess the best known is Lesch-Nyhan disease, which is, I forgot what the gene, but it's a gene that does a very minor metabolic pathway. But if that gene is mutated, you end up with one of the worst genetic diseases, I don't even want to describe it, that anyone has ever had. And nobody knows why, because there's so much complexity in the way genes interact and their gene products interact, that it's not predictable. Will we ever get to the point where we can understand all that? I don't know. But we're very far from it now.
Right. So you raise an interesting worry. And I think most critics of genetic enhancement are really worried about this. That people will just start having this strong optimism of curing all kinds of diseases, making humans smart, intelligent, tall, whatever, strong. Perhaps what they didn't have in their childhood, their own. Perhaps they wanted to be stronger. They didn't want to be in bed, sick all the time. They just see, well, I think if I have children, then they should be better off. I don't want my children to have all these diseases, right? But optimism is not necessarily a bad thing if you're not blind to all these complications you just mentioned. So we need to do lots of research to really determine, well, this genetic alteration is expected to make life go better. But even then, this is a probability calculation, right? And we could be wrong. So you said it's irreversible. To some extent, it is, because you certainly can't change it in this generation anymore. But if you have new data, new evidence that whatever we did turns out to be actually really bad, to actually have a lot of unforeseen consequences, which make the lives of thousands of people perhaps much worse, well, in the next generation you can do better, because you can reverse the change. And this can happen, it's not impossible. And I think to raise this issue that we should make it impossible for something like this to happen is too strong of a requirement, because in that case we couldn't use genetic engineering ever, because there might always be unforeseen consequences.
Right.
Okay.
I think it's kind of a good time.
This is fascinating.
Yeah, I love this topic.
Absolutely fascinating.
We do have some actual questions that are really spot on what you guys are just talking about. So maybe kind of ask some of them now. One of them specifically, if you can kind of address this, one way that you can actually change the way things go through a population is called a gene drive. And gene drives can basically eliminate certain things like malaria by changing the way another species like the whatever the virus is for the mosquito carriers. I can't remember the name of the actual what's the name of it? Ever remember?
Malaria?
Yeah, no, but the actual organism that causes, I can't remember off the top of my head. But you can use a gene drive to actually change the propagation of genes through the entire species. Can you use something like that, or can you describe to the audience how gene drive would actually work to do that? And it ties into another question: should we use that on evasive species like mosquitoes, or you had mentioned hyacinth? There's actually another one, giant hogworth, that has been invading Canada. And giant hogweed is actually poisonous. And if you get on your skin, it causes third-degree burns. Should we use these kinds of technologies to eliminate these kind of invasive species, or are there ethical considerations to be had for that?
Walter wants to take that.
Yeah. Do you want to take that, Walter?
I'll let you take.
Okay, well, I think that's fine. I think that's fine. I mean, there's nothing wrong with gene drive, and I know the work you're talking about. What happens is with the gene drive is you're doing the same thing on the mosquito. You're altering the germline genetics so that all the children of the mosquito have this change, and the change could be just something simple that doesn't allow the pathogen to reproduce within the mosquito. So it doesn't hurt the mosquito, which you don't want to do. The last thing you want to do is eliminate mosquitoes, because then we lose all our birds. That's what I mean by unforeseen consequences. So you don't want to get rid of mosquitoes. You want to keep them, but you don't want them to pass on the disease. So I think that's a great idea. And and in fact, the reason that comes up is because that's pretty close to being done. There are people very close to being able to put that into the field in Africa.
I think they've already started in some places.
Yeah, it started, and well, I didn't know that, but anyway.
I think that's some. I'm going to look into that. Maybe the audience could talk about that. But I think in some places they've actually tried to do something along those lines. This stuff is happening. Yeah, this stuff is happening so fast that nobody can keep up with that. So, but yeah, I have nothing against that. I think that, but you see, that's where you have to be. That's where this whole idea of caution, which I think we agree on, is Walter just said, you have to do research to make sure you're not doing something that's going to bounce back and bite you. And the whole idea, for example, of putting in genes that reduce the fertility of mosquitoes, which is one option that people used to talk about.
could be dangerous, because if you wipe out all mosquitoes, you're
the
stopping
gene
the
drive
food
doesn't
chain
tries
of
not
a
to
lot
do
of
that.
animals.
Yeah, the gene
Exactly.
drive
It
tries not
doesn't
to
do
reduce
that.
reproduction.
That's right. That's right, and that's why these technologies are ultimately good. I'm not against the technologies at all. I mean, I've been in favor of recombinant DNA since the 70s, when the whole thing first came up, and I was so there's nothing
Can you hurry
wrong
up
with
with the
recombinant
pizza
DNA.
thing?
Oh yeah, we have the question on that one. I got to ask that question. By the way, what I was looking
Yeah.
for was plasmodium. I remember it now. I should have remembered
Plasmodium,
We've talked
that's
about,
it.
yeah,
Right.
we've talked about it before. But that goes to the question that I was going to ask earlier, real quick, because a friend of mine had asked me to ask this to you guys. But is there a way to do gene editing so we can eat as much pizza as we want and not get fat? Because if there is,
Please,
I am
Walter,
totally
say
down
yes.
for this. Yeah, I think Walter, you might say yes, right?
Yeah, I was about to say, just to sell my idea, I'm gonna say yes, whatever. But
Awesome.
yeah, I think it's
That's how you do it. There you go.
There you go. He's
Yeah.
got it.
so,
Yeah, I'm all
let's
for
back it
that.
up with some evidence, right? So obesity is kind of the perhaps biggest disease after cancer we face nowadays. We didn't have that a few decades ago. It seems to be an epidemic which spreads through the whole population. Why is that? Well, we're quite ill-adapted to modern life. Well, also our food is really shit and unhealthy, right? But that doesn't really seem to change. You should obviously put some regulations on there. In Europe, we have very different laws than in America, what you can put on the plates of people to eat. I'm not sure that's going to happen in the US. I'm not from there.
No.
And
Never. Like
Yeah.
my Big
in
Mac.
Germany, we have, right, the Big Mac. So what I sometimes do,
what do you?
when I was in Canada a few weeks ago for a conference, I tasted the Big Mac, and well, it tastes different. Why? Because you do use different ingredients. So in Germany, you use this grass-fed beef, and it's kind of nice. It's
Oh, you got
still
beef in
pretty
yours?
unhealthy.
Yeah, they don't put
Yeah.
beef in ours. I don't know what
No?
it is.
Yeah. I was getting ready to say, when did they start doing that? That's a new thing.
Yeah, wait a minute.
Real quick, what are the things that you're talking about where you said that they control what you put on a plate? That's interesting. How do they work that? Like, what are the I guess laws for that?
Oh well, we have research, I guess, and well, plenty of ingredients that are put into processed foods. They are not yet evidence based tested that they're actually not harmful to humans. While there's a very different approach in the US, I guess, where if something is not proven to be harmful to humans, well, then you can sell it, right? But in the European Union, it's a bit different. So if there's something new, but you don't have studies on it, that it's actually not harmful to humans, then you can't just put it into the food of what people eat, right? And I think that seems to be a pretty reasonable idea. By any means.
Absolutely.
Sure. This next question, I think, really kind of goes into what Cy was talking about earlier, and I'll try to just kind of condense it down. Basically, the person wants to know, when dealing with certain things like gene complexes and you have various forms of gene linkages, how do you determine, based upon gene expressions, when you edit one gene, how it's going to affect countless other genes that we don't even know how they're interrelated? That seems to be a huge consideration factor, does it not?
Right. So a big worry is that if we can't test on humans, then how can we actually know what the differences are going to be? We often rely on twin studies for such issues, but that doesn't seem to be enough. And can we actually experiment on embryos? Can we actually do this morally to create a human as a test subject? Well, doesn't seem to be the case. We don't like experiments on humans for obvious moral reasons. So what do we do? Well, perhaps we can test on mice. And that seems to be working behind a lot of diseases. A lot of diseases that are caused in us are also the causes in mice and other mammals. And this is where the research has to go. And in many areas, like perhaps human intelligence, we can't learn that much from doing experiments on mice using CRISPR-Cas, which is a big concern. And perhaps we can never reach this goal of creating these perfect superhumans that are intelligent, brave, smart, super good looking. Perhaps we will only be able to get rid of diseases. But if that's the case, well, that's still a pretty good thing.
But I think the concern is, what about with gene mapping, such that you don't know what else you're changing? If you change one expression level of a gene and downregulate it, and you have a certain protein that's not being produced as much as a consequence as a specific gene being edited, how would you ever be able to predict that if you don't know how these genes are interrelated?
Right, you don't. And even if we learn something new about genes, then we didn't learn everything. And that's going to be the case for perhaps decades. And certainty is really not the goal here. So perhaps, so if you think about the evolution of homosexuality, for example, there's no theory that's very well confirmed why there's homosexuality, because according to evolution, doesn't seem to be the most reasonable strategy for an organism, right? However, one theory is that some particular gene combined with the modern environment we live in causes this. Well, this is one hypothesis, and we don't know. And in many cases, there might be unforeseen consequences. But that's just the issue we have to deal with. It's complicated research, and there's a lot of funding has to go into that, just because the advantages are enormous, even if it's very, very difficult to define what would count as a genetic enhancement in the end.
You know,
I can answer that question for you. Yeah, sure. But let me answer the question about why the homosexual gene came about. Because the world needed a little bit of fabulousness. I can attest to this.
Right.
Go ahead, Si.
No, I mean, I think that the example of homosexuality is actually a serious one when it comes to looking at environment, especially social environment. So when I was a kid, which is a long time ago, but not that long ago, we're talking about the 1950s, homosexuality was considered either a sin, a vice, or at best a disease. And I'm talking about very liberal people still believed that homosexuals should not be killed, but they should be treated. Okay? We don't have that belief anymore. I think if we ask homosexuals, do you think you want to be cured of your homosexuality?
No.
That's laughable, right? They would say no, because it's not a disease. So the point that I'm making is, you know, the environment includes the social, political, whatever you want to call it, current environment of the way people think about all kinds of things, including sexuality of all kinds. And that changes. So that, you know, if we had gene editing in 1955, maybe one of the first targets would have been homosexuality, because everybody would have said, well, it's certainly better to get rid of that. We don't want that around. And in fact, that would have been a mistake, right?
Right. So this is the biggest concern, I think, actually. So a lot of disability rights advocates argue that this whole project of getting rid of diseases is just inherently anti people with disabilities. It's anti.
Well, I don't go that far. Yeah, I don't go that far.
Yeah, that's being ableist.
I don't think that's the case.
No, I don't either.
But let's take this argument seriously. Should we have humans be born with some disease just to decrease discrimination? So perhaps it's just the case. Think of particular. It can be any disability, right? And if it's a small number of people in a society that only have that, then it's not really well taken seriously. take people in wheelchairs. In Germany, almost every place is accessible by wheelchairs in comparison to other countries. And that's a very good thing. And we should do that, obviously. But the worry is that if we treat disabilities as something we should get rid of, then we will look at people with disabilities as inferior people. I don't think that's the case at all. I think we should get rid of disabilities. I think disabilities are a bad thing. What counts as a disability is if it makes your life go worse. And obviously, if there's a lot of discrimination going on in a society, then this itself can make something count as a disability. So let's consider homosexuality. 1950s. It's not that it makes your life go. So the thing that would make your life go worse is discrimination itself. And that would make it count as a disease in this account. If you think of statistics.
Right? Oh, yeah. And look, I totally agree that there's certain disabilities that I think most people would say, fix if you can. If somebody's going to be born without arms and legs, I think that any rational human being would say, yes, let's correct that. My main concern is when you start getting rid of a lot of these other diseases, which I agree with you, should probably be the case, but then you have a huge problem with population, right? I mean, then you're going to have other diseases they're going to come out, and new diseases we've never even knew about that may all of a sudden be even worse because of the fact you have more people living and longevity increases as well. Has that actually been factored in as well in your studies? Walter?
So this whole account is a very individualist one, right? Parents need to be concerned with the well-being of their own children, even if this has negative consequences for the overall society. I don't think those consequences are that harsh, which I go to lengths in my account to defend. But even if that would be the case, I think it's outweighed by the obligation to make the life of your child go better. And if there are such consequences, then it's the job of the state to put limitations there. Perhaps we need to change the environment, or we need to put limits on what kinds of genetic enhancements are legal. Because some genetic enhancements, as I mentioned, might have very negative consequences for everyone around you.
Right.
This was absolutely fascinating. We got to wrap up now because we have another show at 8:00 that we have to get ready for. We are triple threatened today, but I'm going to let you guys kind of wrap up your stances and your points, and also talk about what you have coming up, if anything you want to talk about to kind of close us out. So, Dr. Garte, you want to start us out?
Yeah, I think this has been fascinating, and I'd like to really thank Walter for coming on and expressing the views that he has. And I will say that to some extent, I think I still have concerns, which I mentioned, all of them. But I think you made some very good points that have kind of, make me thinking a little bit more about this, especially what you just said about, having to take responsibility for possible interactions. And to be honest, you also said something that really impressed me, which I hadn't thought about, which is the possibility of reversing a genetic change, which I guess could be done. I guess technically that is possible. It's also possible it might not be able to be done depending on the circumstances. But I think we agree that, the environment is very important, that that we have to be cautious before we go whole hog into, changing the genome and passing it down. And I still have some reservations, but they're more questions. And I think a lot of them are philosophical. And this is the area for philosophers, ethicists, people who really can see all sides of a picture, to really explore more thoroughly. And, it's out there. The technique is there. The technology is coming along quickly. The good news is we're going to make a lot of people have much better lives. That's definite. We're definitely going to cure some bad genetic diseases. We're going to prevent a lot of bad genetic diseases. And that's wonderful. I mean, that's a tremendous advance for humanity.
Awesome. Okay, Walter.
Oh, thank you very much for inviting me. This was very nice talking to you. I didn't have to defend the view that having humans be born with legs and with arms is actually better than having them born without them, which actually I have to defend sometimes. So this has been really beneficial. Yes, some people have extreme views, but if you look at statistics, then humans are inherently bioconservatives. Even the most liberal people hold views that they somehow are still like, well, we shouldn't do this because it's somehow still playing God. But perhaps in the sense, we should play God because we can make the lives of millions of people in the future go better. My intuition here was that many people, their only interaction with this whole issue is some sci-fi show, some novel like Brave New World, and all these shows depict these technologies in a rather negative light. And I think we can look in the future with some optimism that genetic engineering can actually make the world a better place. That is, if we consider research into the environment and limits the state should put on particular alterations of the genome. All right.
Do you want to let people know where they can go, like to your website, to find out more information if they want to follow up?
My website is called walterveit.com. Pretty easy to find, I guess. But yeah, my article is also publicly available, so everyone can download it. It's not written in a very philosophical jargon. I've put it in rather easy terms so everyone can understand it. And it's actually a real pleasure. I think I have more than 2,000 downloads on the paper, which is really rare because most philosophy papers, they're rather in the domain of perhaps 40 downloads and only people in your own domain read it. But I think philosophy needs to get out there and talk to people in the public about issues that concern them. And genetic alterations, genetic enhancements, that's an issue that will be relevant in the future. And that's perhaps much closer than you might expect.
Excellent. Well, this is probably one of my favorite talks that we've done. It makes you think about things that you wouldn't normally before, I think. And you both raised very good points. So I'm still just as in the middle, I think, on the issue as I was before. So
I love these types of discussions. These are my all-time favorite types of discussions.
Yeah, good job. Well, thanks again, guys. We'll see everyone else here at 8 o'clock. Nate Talks to You will be here. Also, Craig Reed is going to drop by, and we're going to discuss the question, can you have a meaningful life without God? So join us for that at 8 o'clock.
And we only need 17 more subs for 10K. 17 more to go.
Oh,
can we do it before the next show?
We might hit it. We might hit it.
Let's see if we can do it, guys. Come on. 17 in an hour. Let's do it.
If you do that, we'll make Steve do the show shirtless.
No, we won't. No. Cut the camera. Cut the cameras.